All right. Good morning, everyone. My name is Jukka Kukkonen, and I'll be talking with you about EVs. But the first thing when I was listening to this discussion here is just consider sometime if you really want to have an official chapter, official organization, because you could just run the things without having an official chapter. That's how we do the Minnesota EV Owners Group. We had 50 people, now we have over 3,000 members. We don't handle any money, we don't have a bank account, we don't have anything, but it works just fine. So sometimes that's the easier way to do, but that's just that's a side thing here. But let's get to the EVs. I will share my screen here, so you should see my presentation slides now. Oh, I'm sorry, I have to do one more thing here. Let me redo this one. Sharing, I'll have to do it again. So I forgot that I have one video, so I want to have to share the sound too. So are you seeing my presentation slide now?
I'm seeing your email.
Okay, well, that's not the right one. Sorry. Someday I get this right. There, share the sound. Now, how about now? We good?
There you go.
It's much better.
Excellent. Good. Well, yeah. So good morning. My name is Jukka Kukkonen. I'm Chief EV Educator and Strategist for Shift to Electric at my company. And this presentation that I'm doing with you is sponsored by Fresh Energy, that is clean energy advocacy organization in St. Paul. So if you don't know about their work, go check them out. They do a lot of really good stuff. Couple of words about myself. Usually when I start speaking, people pick up my Wisconsin accent. And then I have to do a little correction and say, yep, you're right about the direction, but you have to go a bit more to east. I'm actually originally from Finland. So I'm an automotive engineer by training. I used to work for Ford Motor Company in Finland. I left the automotive industry in end of 90s and went into consulting and training, met my wife through that way. And of course, my wife is from Minnesota. She grew up in Bloomington. And then when we decided to get married, we had to flip a coin if she's going to move to Finland, if I'm going to move to here. And I don't know if I won or lost, but I've been here for the last 20 years. So that's my story. For those years, last 12 years, I've been working with electric cars, looking at the market from technology standpoint. I started to see that electric vehicle technology is maturing in a way that it will become a viable option for us. So I decided it's time for me to get back to the automotive industry and start working with this. So as I said, I've worked with EVs for the last 12 years. My company Shift to Electric, I do consulting through that to companies, helping them to figure out what's their place in the marketplace. I've done quite a bit of work in charging infrastructure with apartment buildings and condos, figuring out the best solutions for that. Workplace charging too, the same thing. You can find information on those about that from those sites. And then I coordinate the Minnesota EV Owners Group, which I just mentioned. We started that in 2012. We had 50 people in the group. Now we have over 3,000. And that's really good group. We do all kinds of events. The picture that you can see behind me, for example, is from State Fair. We have had a display there for the last 8 years. This year we had 4 cars or 4 vehicles there on display. The red one that you can see behind me there, Ford F-150 Lightning, of course, was kind of the star of the show this year. Then next to it was Ford Mustang Mach-E. I'm sorry, Tesla Model Y, then after that, Ford Mustang Mach-E, and then Polestar 2. So when you go to State Fair, always check out the Eco Experience building that is run by MPCA. We usually have a display there. And on that display, in addition to the cars, we have some charging infrastructure. Then our EV owners are there to talk with people about their experiences, about what is it like to own, charge, and drive electric vehicles in Minnesota. I'm also EV market expert at Fresh Energy, and I teach EV market and technologies course at the University of St. Thomas to graduate students. We're just starting this fall course this next week, so that's always fun. And in addition to that, I'm also now bringing the European manufacturer Kempower DC fast charging systems to the US market, and I'm representing them here. So I can speak pretty objectively about charging infrastructure in general, but if someone asks me what's the best DC fast charging stations out there right now, I'll say that's Kempower. So just to be frank about that. Here's a picture of my family in 2012. That's 10 years ago when we got our first Nissan Leaf. As you can see, I was looking much more handsome at that time, but that's how things changed. My daughter was 8 years old at that time. Now she's 18. My son was 16. It was 6, and now he's 16, and he has a driver's permit right now. So we actually have a used Nissan Leaf that he's driving now, getting his license right now. But we've had several different EVs over the years. We've driven 10 years with electric cars. Really good experience overall for us. And by the way, I'm doing here a presentation that would take about maybe 35 minutes. I'll go through all the slides here, and then at the end of the presentation, we'll have a Q&A session where you can ask all the questions. We can go back to some of the slides if you want to ask something specific. But if you can hold your questions to that time, we'll probably get through this the best. So why are we talking about EVs in general? Well, we have to go back to the internal combustion engine time here. Being an automotive engineer, I always have to start with the technology. And as many or all of you know, internal combustion engine has been used for the last 100 years, and it's a pretty complicated machine. It has served well for us over those times, but at the same time, the challenge with the internal combustion engine is that we are trying to capture that is in energy that is in chemical form in gasoline and transform it into propulsion power for our car into mechanical form by using small explosions. And using small explosion is not the most energy efficient way to do anything. It might be fun, but it's not very efficient. So therefore, internal combustion engines are between 15 to 25% efficient. So that is the challenge with it. Someone has actually said that the internal combustion engine is excellent heater, and as a side product, we get some propulsion power out of it too, which is exactly what it is. It is mainly a heater. Secondary, it's providing us propulsion power. Well, if we compare this to electric motors, which again have also been used the last 100 years, the difference is pretty big. We look at electric motor, AC induction motor, like here in this picture. Actually, this might be a permanent magnet motor, but anyways, has just one moving part, the rotor. So it's much more simple and also much more efficient. We're talking about 85 to 95% efficiency. So it's 4 times more efficient than internal combustion engine is. And that's what the big difference is, why we are moving into electric vehicles. And that's why I started to realize that electric vehicle technology will take care of this game, because internal combustion engine just can't compete with the efficiency, and it's going to be a huge thing. And you could ask, well, okay, if we have had these electric motors already for the last 100 years, why haven't we already moved into this technology, let's say 20 or 30 years ago? Well, the challenge was on the battery side. If you think about when we got our first mobile phones, and you got one of the mobile phones, and then you had to carry this big suitcase of batteries with you. That's where we were with batteries at that time. But that has changed a lot, and that has enabled us to have a longer range EVs now available in the market. So battery technology advancement is the biggest technology difference there that has happened in the last 10 years, for example. Here's a graph from 2010 to 2020, lithium-ion battery prices. So in 2010, for example, the lithium-ion battery prices were over $1,000 per kilowatt hour. And now we are starting to reach $100 per kilowatt hour. So there's a huge difference in that way. Let's take an example. Volkswagen ID.4, that is one of the new EVs available in the market. That one has 78 kilowatt hour battery pack. So if Volkswagen would have built that vehicle in 2010, just the battery pack itself would have cost over $80,000. Now, this year, they might be able to build the same battery pack for $8,000. So there's a huge difference. And that's why we are seeing long-range EVs coming to market. That's why manufacturers are starting to make money with EVs. So they are realizing that they can actually make the shift into this new technology. At the same time, we are seeing a big shift to renewable energy. So electric utility companies are moving into renewable electricity production. So they're closing their coal plants, and this is happening really rapidly. Here's an example of Excel Energy's carbon emissions from 2005. If you look at how fast that graph has already dropped to this day and still continues to drop. So our grid is getting cleaner, which means that we are getting cleaner energy. And of course, that's great for our electric cars because they are already cleaner, but then they just get cleaner every day without us having to do anything with it. So that's another good advantage there. Talking about emissions, just to give you an idea, what is the difference? If you are, here's an annual well-to-wheel car emissions by fuel type. So if you're driving the traditional internal combustion engine car for 12,000 miles a year, you're producing about 11,000 pounds of CO2. With electric, using the grid power, you are producing only 4,000 pounds of CO2. Remember, much less energy, higher efficiency, much less energy consumed, of course, lower emissions too. That's the big difference there. But if you look at these numbers, these are from 2014. And I just showed you a graph how fast our grid emissions are dropping. So that number is not 4,000 anymore. What is it? Maybe it's 3,000, 3,500. I don't know. But again, just reminding that it keeps dropping all the time because grid is getting cleaner. And at the same time, EVs provide us an option. They provide us a freedom to choose how we power our driving. We can just use the plain vanilla grid power, or we could put solar panels on our roof and then use more renewables. And of course, drastically still lower our emissions by doing that. We don't have that options with internal combustion engine. We are pretty much stuck with all of it. So that's a huge difference there. If you look at the technology, in general, it's pretty simple. As I showed you, the motor is very simple, but so is the technology in a car. When you look at that, you have a battery pack underneath the vehicle there. This, for example, is Volkswagen ID3. I think this photo from ID4 has a pretty much same thing. So you have a battery pack, you have motor in front and motor in back. So you can have a 4-wheel drive. In this case, this might not be a 4-wheel drive. This might be only a rear-wheel drive. But you look at the unit on the back, you will have the same in front. That's how easy it is to make an all-wheel drive vehicle out of the electric car. Then you have a charging port. You have a charging unit there, and that's that. Motor controls and all of that are usually right by the motor, so everything is integrated. So it's a very compact unit, and again, making things simple. So that's what that looks like. If you look at the, for example, Ford F-150 Lightning, the same technology there. You can see the battery pack again underneath the vehicle, the charging port by the front driver's door there. Then you have on top of the motor there the controls, of course, but on top of that, the charging system, and that's that. Very, very, very simple from technology perspective. Let's talk a little bit about market, what has happened with the EV sales in recent years. In 2020, battery electric vehicles and plug-in hybrids that are combined as EVs were 2% of the US sales. Last year, they doubled, the market doubled to 4%. Right now, the first half was 6.4%. So it's growing steadily again here, and there's no reason. We are actually going to be seeing the biggest change in the whole automotive industry that we have seen pretty much since T Ford. this thing will change fast, and I'll show you a couple of other slides that show you how that is happening in some other markets. We are not seeing it yet totally here in the US, but it's coming very fast. If you look at the 12 most sold EVs in 2021, so last year, you can see that Tesla is just totally ruling the market. Tesla Model Y was the most sold in this class last year, and you can see the next comparable one to that is Ford Mustang Mach-E, and Tesla sold 6 times more Tesla Model Ys than Ford sold Mustang Mach-Es, and they're very similar vehicles. And you'd ask, like, is Tesla Model Y 6 times better than Ford Mustang Mach-E? And then when it gets even weirder, when you start to think about that, Tesla Model Y is $10,000 more expensive than Ford Mustang Mach-E. And you're like, how's this happening? Well, there's just a simple answer to that: availability, plain availability. Right now, the market demand for all the EVs is through the roof. It's just enormous right now. And I'll come back to that in some other examples. But this is a very good example because Tesla actually has a production capacity. They have been able to produce vehicles. They've been able to sell more. Whereas Ford didn't have enough production capacity for Mach-E, so that's limited by that. Volkswagen ID4, for example, they had 16,000 units that they were able to sell in the US last year. They had 40,000 people on top of that waiting for it, and other vehicles the same thing. But I'll come back to those. If you look at right now, the first 6 months this year in the US market, and we look at how, for example, Tesla is doing, because Tesla is the only it's the clearest example of pure electric manufacturer in the US. It's right now in a number 14 on the manufacturers list. So I'm sorry, it's 12, it's 8, it's 12. It's 12 the biggest seller in the US right now, with the market share of 3.3. It increased last year from the same period almost 50%. And if you look at all the other manufacturers, they have struggled to actually produce the vehicles, so they have had very big negative drops, whereas Tesla has just kept on increasing. So this is a very good example of how Tesla is just totally eating the market share of other manufacturers. When other manufacturers have been slow to move, Tesla is just eating up it, and it continues to do so. And anyone who keeps still saying that, well, there's not enough demand for EVs, just doesn't either understand the market, or B, they have some political reason why they are talking that way. Those are the only reasons why that is. Because right now EVs are so high in demand that anything that can be produced will be sold. Tesla is a good example there. If you go down there, you can see Polestar has a huge, like 800% increase. That's because they were not selling too many units last year. They had just started. So that's not really a comparable, but still a good example of how things are moving. If you look at some the other markets a little bit, US and European sales, you can see that US sales have actually grown really slowly because we haven't had a robust requirements here to actually for the manufacturers to bring the vehicles into the market. When European Union put more robust emission standards in place, which required manufacturers to bring the vehicles in the market, they had been saying that, well, I don't know if there's enough demand or if there's enough charging infrastructure and all of that. Well, when they actually had to bring a good number of EVs in the market just took off. And you can see the huge growth there because people were just waiting for those vehicles to come. And we will see similar things here when the vehicles will be better available. Example from my home country, Finland, which is 1/3 bigger than Minnesota and has the same population. So it's more sparsely populated than we are. Same way, longer distances, actually people probably drive longer distances in Finland than we do here. They have colder winters, shorter summers, so it's harder environment in every way than Minnesota is. And here's an example how their market has grown. 2017, they were in the same situation where we are, about 45% of market EVs. Then if you look at last year, they were at the end of the last year, they were over 30% already. They have had months now with 44% of the market there being EVs. So this can happen really fast when the vehicle availability just improves. McKinsey and Company is expecting that in 2030 we'll see 53% of the market being EVs. They have been increasing these numbers all the time. So a year from now they might already say higher, give us higher numbers, but that's the that's what they are saying right now. As I said, again, this is about the availability. I'm expecting this could happen even faster. Here's one video for you that I wanted to share, so hopefully you can hear this and see.
Did you know that Norway sells way more electric cars per capita than the US? Norway. Well, I won't stand for it. Come on. Never mind. With GM's new Ultium battery, we're gonna crush those losers. Crush them! Let's go, America. Keenan, Norway's out EVing us. Wait, what's this?
Oh, it's my daughter's birthday. She's really into pirates
I don't
lately.
care. Grab an EV, meet me in Norway.
Okay, can I say goodbye to my family?
Nope.
All right.
Aquafina, sorry to disturb you, but Norway's beating us at EVs.
Nuh-uh.
Uh-huh.
Nuh-uh.
Uh-huh. Meet me there in an hour.
Can I ride with you?
No! GM's Ultium battery is made for all types of vehicles, so soon everyone can drive an EV. Whoa!
Why didn't we all just go together?
Knowing Will, he's probably flying private.
Hey, Norway, listen up, you fish-loving! Oh, this place is adorable. Damn it. Where are you guys?
We're in Finland. Where are you?
I'm in Norway!
Norway? You're in Sweden.
Damn it!
Let me try to get moving forward here. There. Yeah. So I think that's just a good video showing a little difference there and little competition. And I think it's good if we see more of this competition because we are so losing to Norway right now. Norway, the EV market share in Norway is over 90% right now. Just this year, I just looked at 1 month, January, Audi Q4 was the most selling EV in Norway. And it actually sold 1.5 times more than all diesel and gas vehicles combined that month. Just one model. And it wasn't like it was anything different. I could probably pick up another one and get same kind of results, but it just tells you how fast the whole thing will change when people realize it and get an opportunity to drive EVs because they are just better cars. There's no question about it. All right. One big thing that we have seen, of course, that has made this happen is that the range has changed. We used to talk a lot about range in past, and an average driver in the US drives 37 miles a day. So that's where I have the blue line there. When we got our first Nissan Leaf 2012 that you saw in the picture there, that had 73 miles of range. It actually worked just fine for us in everyday driving. You didn't take it to Duluth, but for commuting, it was perfect car. Even in the coldest winter days when you might only have half of that range available because that car had a small battery, it still was okay for our driving here in cities. But again, it was somewhat limited. Well, then comes 2018, and Nissan Leaf at that point provides 150 miles of range. Then in 2019, the same vehicle, you can get it even with the bigger battery. It has 225 miles of range. So it's 3 times more range than the Nissan Leaf had 2012. And that's what has happened. Again, I showed you how much battery prices have come down. Manufacturers have put bigger batteries there, improved the efficiency just a little bit more there. And then we have vehicles that have way different range than what it used to be in the past. We have quite a bit of different models that are between 220, 280. We have some more models that are over 300. And then we have some models that over 400 up to 500. Lucid Air, for example, can go over 500 miles of range. There was one reporter who tested the range of Lucid Air, and he does a 70 miles per hour flat. So he goes in the highway, drives 70 miles per hour. He had to drive almost 8 hours with that car to get that. He stopped for a bathroom break. He didn't and to eat, but he didn't charge it that day. So you can actually do a distance with these vehicles. That's not really an option, problem anymore. And of course, for those who are still concerned about the range, you can always choose a plug-in hybrid. With that one, every morning your first miles are electric, 20 to 50 miles. And then after that, it goes into hybrid mode and you can drive wherever you want from there. So that works well. But most of the people drive, their everyday driving might be that 37 miles, and they might be able to do the whole thing in electric. So maybe if they drive 12,000 miles a year, maybe 11,000 that is actually on electric, and only 1,000 of it is in hybrid mode using gas. So that's of course a good option for those who want to still have a more flexibility in their system. If you want to learn everything about vehicles that are theoretically at least available right now, you can go to evinfolist.com and download a list of vehicles and their specs that are available in the market. So that's the best way to do that. I'll just type it here. So one comma there. There we go. No, of course it wasn't supposed to be comma, it was supposed to be. Let's do this again here. There, that should work. Anyways, so you can find it now on the chat there. But we try to keep that up to date. That's 5 pages long right now. Again, the challenge right now is the vehicle availability of finding those. So my suggestion is, if you find something that you like, don't even try to pick up the right color. If it's find the right car, just get it. EVs have been a smart money move already for the last 5 years. And that's what people have realized. That's why they're going so fast right now. So there are more bigger vehicles coming into the market right now. So we have crossovers, SUVs, and pickup trucks coming right now. Last year, we saw most of the new EVs going to crossover area. Crossovers are actually right now, I mean, if you think about in US in general, we used to buy either smaller sedans or big SUVs. Nowadays, the market has kind of moved more in the middle. So crossovers are by far the biggest segment in the US market. 45% of the vehicles in general that are sold as new vehicles are crossovers, and that's why it's good to see most of the EVs coming into the crossover area. So there are some of the vehicles, models that came available last year. We have more that have come this year. There are some of these that have still not arrived to the market. They will still continue to come next year. So, but really excellent cars. All of these vehicles that have come to the market, people are just doing it when they're testing. They're just really excited about them. They love the vehicles. And as I've said, EVs are just car 2.0. They're just so much better in every level and it's hard to understand if you don't test drive them. So that's why if you have an opportunity to test drive EV, go test drive it if you haven't done so yet. So that's that. Of course, the electric pickups are also coming. Ford F-150 Lightning that you can, again, we had on display, and you can see it behind me there. That one Ford has just started to bring it provide it to the customers. They had an opportunity for people to take reservations last year, or do the reservations last year. They stopped taking reservations in December when they had 200,000 people already put the reservation down for it. Then they started to give people an opportunity to order them, and then they started the deliveries this spring here. They can maybe make 20 to 30,000 units this year. Maybe next year they can make 100,000 units. So they can't even get through the reservation holders within next 2 years. And anyone who drives that truck will realize that, oh boy, I want one of these. If they need a truck, that is by far the best option for them. So that reservation list will continue to grow whenever they open it up again. Right now, they are just not taking any reservation. They had the same thing with the Mustang Mach-E. They stopped taking orders because they had so long list that they had to slow it down. But now they opened up the Ford Mustang Mach-E orders again. Rivian is just coming to market. They have also started the deliveries. I think they have like tens of thousands of people who are waiting for it. The Hummer, the same thing. And even if I don't happen to like the Tesla Cybertruck design, there are a few people who do, because that has 1.3 million reservation holders for the Tesla Cybertruck. So hopefully Tesla will start to produce those next year, hopefully early next year. But as you can imagine, as many as they can make, there will be takers for them. So this is a pretty amazing time in the automotive industry. We have never seen this kind of change and this kind of shift in the market. So it's cool to see. All right, then a couple of words about charging. So most of the charging happens at home. That's one thing that people don't necessarily always understand. They first ask, well, do we have enough public charging stations? My answer to that is yes, we have a decent number of them and more coming all the time, but most of the charging happens at home, as long as you have an opportunity to charge at home. That's of course one limitation there. But based on the surveys, they say about 85% of the charging happens at home. If people have an opportunity to charge at the workplace, they'll do that too. And then public charging is important, so you can drive long distances, but people use it much less than you would initially think. These numbers say that it's 5%. In our life, for example, my wife has driven now 10 years with electric cars. She has never used a public charging station. I only use public charging stations if I drive long distances. Tomorrow, I'll be driving to Duluth, and on that trip, I'll be charging once on that trip in Duluth before driving back. That's where I use a public charging. So how to do the charging? Every car comes with the 120 volt level 1 cord set. So one end of that is J1772. That is standardized plug for all the vehicles. Tesla uses a little different plug, but they have a small adapter, so they can also use that if needed. And then the other end is just normal household outlet plug. So if you have a 120 outlet in your garage, you can start driving electric. You don't necessarily have to do anything more than that. That cord set works well if you drive less than 30 miles a day, because we are limited by how much we can pull power out of that 120 outlet. So it has that limitation. If you drive more than 30 miles a day, then I would recommend installing a level 2 charging station. The one on the right there is a public charging station. The one on the left there is an example of home charging station. Home charging stations are usually between $500 to $600, and then the installation cost depends on how close is your breaker panel box to wherever you're going to install the charging station. If you have breaker panel in your garage, it's usually not that expensive to do the installation. And the idea with level 2 charging is that with that you can charge the battery full overnight, no matter how much you drive. So that's how that is. And then of course DC fast charging is the fastest way to power your driving. So those ones you would use on the side of the road when you're doing long distance trips. And usually that's a 30 to 40 minute stop for that. So you drive 2.5 hours, and then you stop to have a meal or something like that. I just went to La Crosse 2 weeks ago and had a meeting there. After the meeting, I was like, okay, well, I should probably charge a little bit so I can get back to cities. I went and bought the sandwich and went in the supercharging station, plugged the car in there, and started eating my sandwich. And I was like, okay, when I reach 200 miles, then I can just leave. I didn't get through halfway through my sandwich before the car was already ready to go. So that's oftentimes a challenge for me, is that it takes longer for me to fuel myself than the car to fuel itself. So that's how it is. Here's an example of level 1 home charging. For example, we are here showing how to charge our Nissan Leaf with just the cord set that comes with the car. If you use this setup, just have an electrician to check that your connections are good and everything is working well there. Then a quick calculation of your charging costs. So if you drive about 1,000 miles a month, which is pretty average for people, EVs, you can find exact efficiency numbers from fueleconomy.com, but if you want to do just a rough number calculations, you could say 3 miles per kilowatt hour is what you get for the cars. If you're using pickup trucks, if you're getting a Ford F-150 Lightning, then I would say you're talking about 2 to 2.5 miles per kilowatt hour, because they are bigger, they have a poor aerodynamics, so they do use more energy. But if you're talking about the cars, we're talking about roughly 3 miles as a good average number. So if you drove 2,000 miles, you get that efficiency. You just use 333 kilowatt hours a month. If you pay just regular flat rate for your electricity, let's say 12 cents there, your monthly costs are about $40 for your driving. If you take advantage of time of use rate, so getting electricity practically half off during off-peak times, most of the utilities do offer this option, then maybe you're paying only 7 cents per kilowatt hour for your electricity. So then your monthly costs are $23 for all of your driving. And then you compare how much you pay for your cell phone every month for that connection, and you realize that your driving doesn't cost you anything anymore. EVs do provide also a maintenance advantage because of the much simpler drivetrain technology. So here, for example, is a Chevy Bolt EV maintenance schedule. So it says rotate the tires once a year, replace the cabin air filter every 2 years. That takes about 10 minutes. You can do it yourself. Replace the brake fluid every 5 years, and drain and fill the vehicle coolant circuits every 150,000 miles, and that's it. So usually I say, if you know how to put air in tires and windshield wiper fluid, you're pretty far with EV maintenance already. Then you compare this to the traditional internal combustion engine vehicle maintenance schedule, and you get the normal laundry list, which will make sure that you will stop at the service department often enough to get those done. So those were my slides. Now it's time for Q&A. I'll just give you one more resource. We have the mnevbio.com website where you can find just the basic information about the EVs. So check that out if you wanna learn more. But I'm happy to take any questions you have about the topic. Talk about the EVs, the charging, cars, whatever you like.
Okay, I'm Mark Persons, and I'm an advocate of. Wait a minute, let me get my video going. I'm an advocate of doing EVs. I do live 150 miles away from the Twin Cities, so to me it isn't quite working for me. But I keep watching it, and I see you've got up to 400 miles of range. That's looking good. Did you hear? And that the governor of the state of California was pleading with people during the air conditioning season not to charge their electric cars. Did you hear that one?
Yeah, the challenge there is not so much of electric cars. The challenge is our leaky homes. If you think about the home construction in California, they really don't have any insulation in them too much at all. And that's why they have to be running the AC system so high all the time. So it's the AC load that is providing the problem. And EVs are just, the good thing about EVs is that it's very flexible load. You can charge the car whenever it makes more sense to you and when it makes more sense to the grid. For example, I never charge my car during the daytime. The only times I do it if I want to take advantage of my solar panel production. That's the only thing. But usually you just charge it overnight. My car starts between 10 p.m. and 6 a.m. and that's how you use them. One of the challenges with California is that because they have actually encouraged people to charge during the daytime in many times, because they have excess solar production usually during this time of the day. I mean, in a midday, they have so much solar production that they have had to curtail some of the things. So they have told people, hey, you could charge during the daytime. Please charge during the daytime so that we can actually take advantage of this electricity. Now they are going back and saying, okay, now is not time not to do that. And this is where we need the good, smart, bright minds to build systems so we don't have to do this manually, but the system will automatically do that and say, okay, today the prices are high, because that's what happens. The market prices go high. They're like, okay, today you shouldn't be charging during the daytime. They know that 24 hours ahead, so their system should have already started charging during the nighttime when the AC systems are not running that high. So it's all about, we here in US have been used to having very flat rates for electricity. No one has to think about it at all or any of that. And we are moving into area where you actually start to have to match the consumption to the production and the other way around. And it's much more dynamic, which in many ways is very, very good, but it just needs a little bit more thinking. So that's what we are seeing.
Okay. On another matter, I've been involved with batteries my whole life. It's kind of something I like to think about. And when I think about fast charging, I think about batteries getting hot and shortening their life. What's the plan there with the current batteries?
Well, the deal with the batteries is that, of course, the battery sizes have gone so much higher that it's less of an issue with those batteries than what it used to be with the smaller batteries. As you know, in batteries, we talk about C rates. C rate, it means how fast you are charging it or discharging it compared to size of it. So if you have, for example, Nissan Leaf had a 24 kilowatt hour battery pack, and it was charging with 50 kilowatt charging. So that's over 2C rate, which starts to be on a higher end where you would like to do the fast charging. Now the same Nissan Leaf has 60 kilowatt hour battery pack. So even with now it's less than 1C if you're charging it with the 50 kilowatt power. You can now go up to 180 kilowatts or 100 over 120 kilowatts, probably like 150 kilowatts charging power to get the same kind of a C rate. So that has helped a lot. At the same time, we have active thermal management systems in the batteries. So they are liquid cooled, liquid heated whenever needed. So that takes care of that also, is that when the battery temperatures start to rise, it immediately starts to cool down the batteries for that. So it's interesting actually that oftentimes when vehicles are going into fast charging stations, like let's take an example of Tesla, which has the most advanced systems in this. If you put their navigation that you're going to the next supercharging station, the system starts to actually heat up the battery so that it gets higher in temperature, so that it can charge faster, because it likes to be in higher temperatures when you do fast charging. And then when it starts charging, if it reaches a certain temperature, then it starts to cool down the battery a little bit to keep it in the right level. But it's much more advanced technologies that are used nowadays for that. Other questions?
Yeah, I have one for the home. What kind of capacity should you have for your coming into the house? Like, mine's like 100 amp service, and unfortunately for me, my garage is in one end of the house. The service is on the other end, and I've got a drywall basement, ceilings, all that stuff. So it'd be a mess to try to put 240 into the garage or 220 into the garage. But I'm still just finding out, do I have enough service coming into my house to start with?
Yeah, 100 is a little bit on the lower end there. You can probably do that, but at the same time, you will probably have to run anyway a separate line to the garage to do that. Is your garage by the alley, and is the power coming from the alley to your house?
No, I live in a cul-de-sac, and all our transformers are on the ground.
Yep.
And my transformers are direct opposite, 180 degrees on the circle on the opposite side, more or less. So okay. I don't know how they'd be able to get it to feed into. So I should call the power company
you
sometime.
To find where your main meter is. I mean, look at that and look at the proximity to the garage. And I would actually recommend probably running a separate line to the garage, and put their second service for that, because then you have plenty of power there available. At the same time, if you don't, for example, have solar panels on your roof, someday you might want to do that. Then that allows you more power capacity there that you can actually add add those in your garage. I have actually in my house, I have, let me see if I can change my background here. I can. Let's do this. So here you can see another background here. This is my garage here behind me now. So I have solar panels on my roof. I used to have a garage that was from 1950s, and it was just a one-car garage, but it was so full of bikes and building materials that I could never park a car there. There was no way to do that. And then my wife was begging me to build a new garage for a long time, but I wasn't really willing to do that if we couldn't do something else there at the same time. But then there was a big tree that was covering our alley area there on our neighbor's yard. But my neighbor cut that tree down because it was an old tree at some point. And then I was like, boy, now we have a good potential to also put solar panels in. So I designed the garage that you can see behind me there so that it has a lot of south-facing area. So then we built the garage, and then later I installed the solar panels on top of that. So that was a part of the deal there. But what we did at the same time, I had just 100 amp power in my house, and I had just run a small conduit to the by our alley so I could charge our Nissan Leaf outside. Worked just fine for it. But when we built our garage, I actually put the main service, moved it. I had an aerial going into our house. I moved it into our garage. So I had the excel energy to move it there. Now I have a 200 amp panel in the garage, and then I'm sub-feeding our house from that panel. So that way I didn't have to touch the house panel at all, but now I have plenty of power capacity available for EV charging, solar panels, whatever. I have a storage batteries in there. I also have a microgrid, all kinds of fun science projects, but that helped me in my situation. So that's one way to think about it. If you want to kind of change the setup, and in my case, it made more sense to just move the aerial wires from our house to the garage, put the main panel there, sub-feed the house, and do it that way.
Thank you.
And then I'm sorry, power levels. I didn't actually answer your question. That was just a long answer and didn't provide the answer. The answer to that is usually you talk about 40 to 50 amp, 240 volt power there. So that's usually what is used for the level 2 charging sensors.
When I think of batteries and winter, I think of batteries that don't perform well when it's 20 below zero. How do you address that?
Well, as I said, all of these have an active thermal management system. So if needed, they will actually heat the battery so that they stay in a ideal temperature. So that's how it's done. So they keep the batteries in a decent temperature all the time, the system itself. But you're right, if they would go really, really low, they would provide less capacity. And you can see that, of course, in the wintertime, you can see a lower range for EVs. That's a very, very, very real thing. There's no question about it. I would say roughly a third lower. But if you have 250 miles, average range of new EVs sold right now is 250 miles. And then you just, if you in a coldest day, you get 160, 170 miles of range. Okay, as long as you know it, you're fine. For example, me, it's not very often that I drive those distances in a day.
What I see on the horizon is wireless charging of electric vehicles. And as a now retired broadcast engineer, I think about the RF spectrum and do the devices we have comply with FCC rules for incidental, unintentional radiation. And I could see 8 or 10 kilowatts worth of energy being transferred from the floor of the garage to the car. And I see a potential there for radio interference.
Yeah, that's definitely would be a real thing. We have had this technology available for the last 5-6 years already in commercial level. It really hasn't taken too much off. And the big reason for that is that it's not that complicated to plug the power in. It's way more simple, and it's way more cheaper. Of course, you have a losses when you have a inductive connection there compared to conductive. So therefore, people are not that excited about it either. And it's, as I said, the units are more expensive. So I can see that playing some role in the future, definitely probably more of it, but it hasn't shown we haven't seen a big movement towards that. It might take some time.
Are there any systems in Minnesota right now with wireless charging?
I'm not sure if anyone has actually installed it in Minnesota, but
Okay.
again, systems have been available, but that just tells you that the take up hasn't been very big, because it is expensive, and then you lose every time you charge. Let's say you lose 10 to 20% at least. You're like, why would I just waste that energy when I could just plug it in and there's no losses in that connect?
I would worry about a cat or dog crawling under the car while this is all going on. They might be fried by the time the day is over with. I don't know that, but it strikes me as possible.
Yeah, I think they have systems to prevent that. The manufacturers have looked into that for sure.
Okay.
So that's that. But again, I don't see that system being too often used. I can see it used in some fleet cases, where fleet vehicles where they stop for very short periods of times, and the drivers wouldn't have to worry about it. That would be one option for it. But even in those cases, we are now starting to see a mechanical, like robotic connections happen. That there's a robot that's just kind of like puts the plug in place, and then again, there's no losses in that connection. So it's better that way.
Can I assume that there's no way to run the vehicle if the charging hose, so to speak, if the charging cable is connected? Is there some sort of a prohibit on that kind of a thing?
Yeah, exactly. It don't move anywhere. So
Okay.
it doesn't have the same old technology problems that we have with the gas pumps, people driving off with the hoses still connected.
When I think of electric vehicles, I think of switching power supplies or variable speed motors, which are which it can create radio interference. What have you experienced on your cars with AM radios in them?
I haven't seen too much problems, but I don't listen to AM radio, so that doesn't put me in a good spot. I don't listen to radio. I mean, I use some, but I don't listen to AM radio, so therefore I don't know.
You're speaking with broadcast engineers today. You understand?
I know. Yeah, I understand. I'm not the not the best customer maybe in that way, but that's just where we are. So unfortunately, I can't really speak too much about the topic.
Does your car even have an AM radio? My last car did not.
Very good question. I don't know.
I wanted to ask, I read an article at some point about the power grid, and if at a certain point they were arguing that the power grid would get saturated if everyone had electric vehicles. Are power companies seeing that and building out their grids more, or was that person worried about something that's not an issue? Or
well, it definitely can be a issue. It depends on how we do things. And as we just talked earlier about how things are moving into more dynamic, it's not the static anymore. You don't do just control statically. You have to be more dynamic with your controls. The same thing, I mean, is true in a general scale when it comes to the EVs. We can do things dumb way, or we can do things smart way. If we do things dumb way and everybody just plug their car in when they come home from work, they just plug the car in and car starts charging right at that moment, 5 p.m. That's when the grid has the highest peak already. And in California right now, that would not be a very good idea. Same applies to Minnesota in the hottest days. It would not be a very good idea to do that. But that's pretty easy to control. It's not too complicated. So that's why, for example, utility companies are providing these time of use rates where they have the electricity half off during the nighttime to incentivize people moving their charging to nighttime, which is very easy to do for people. They just set up their car so that it doesn't start charging until midnight, or that it's ready at 6 a.m., which I usually do it so that my cars are ready at 6 a.m. I just set up that once to the car and forget it, and it does that every day. I can plug the car in any time. The car will just start to charge whenever it needs to. Make sure that it's 6 a.m. next morning it's full. And the good thing about this, of course, is that we have excess power oftentimes in the nighttime in the grid, and also wind, which we are having increasing amount in our Midwest grid here, is actually usually blowing hardest during the nighttime. So you can take advantage of those resources to power your vehicle during the nighttime, and you're not putting stress to the grid. Utility companies actually love this whole thing. They're really happy about it, but they also aware that you have to do things smart way and just not do it the stupid way and just not tell anyone how to do it. If you inform people, provide good incentives for them to do it, they'll move their charging to night.
Do you know about anything about electric motorcycles? I thought I saw one out here the other day, and curious how common those are becoming.
They are very, very cool. We are starting to see more and more of them. I was just talking. Who was I talking to? Oh, I did a presentation the other day here, and they said the person that I spoke there, he's like, "Oh, I just got an electric motorcycle." And the cool thing about those is, of course, they are very quiet. They are pretty powerful. They're really, really fun to drive. So we will see more and more of those available soon here. And definitely, I'll give you an example of, for example, electric ATVs. My brother has a farm in Finland. They actually have horses there, and they used to have traditional ATVs to help with the tractors. So, for example, in the daytime, they go to the lake, fill up a big tank of water tank that is pulled behind ATV there, and take water to the horses on the field with that. And they also do the same with the hay. They take the hay to the horses to the field, and they have used traditional ATVs for that. Then they got a Polaris Ranger EV, which is electric ATV for that job. And they've used that now 4 years there. And they're like, this is the best thing ever for it. Because first of all, it's quiet. You don't have any noise pollution. They can go in the middle of the night to do something with it, and doesn't do that. And the power curve, of course, it's because it has full torque from the zero. It's much easier to control that. So, for example, when you're coming out from the lake on the uphill on the bank there, with that, it's much easier to do that with the EV. And of course, it's cheap as heck to drive. Doesn't cost them anything to drive it. So they've been really happy with it. So that's a good example. We'll see the similar kind of things with motorcycles too. Any other questions?
There's a
One
couple
that-
in the chat. Sorry,
Okay.
Tom, Taylor.
No, I
Yeah, can you
was just
please?
about to say the same thing.
Yeah, if you can please read the chat questions to me. I haven't been watching the chat, so.
Are accidents in an EV more dangerous with battery being located underneath you?
Good question. No, they're not. When you look at the EV crash ratings, they have a very good crash ratings, all of them. They are very safe cars, so no difference there. To be able to puncture the battery, it takes a lot of energy. There has to be really, really big accidents, and in those accidents, it doesn't really matter in which car you're at, because then the car will be in 2 pieces or something like that anyways. So in general level, yeah, I would say they are safer than traditional vehicles, based on what we see.
I have a friend who's a fireman, and he says that they have books in their fire engines to tell them how to disconnect the battery in an accident situation. So they know how to do it to keep it safe.
Yeah, and generally for first responders, the recommendation is to behave with EVs exactly like you would with any other car. You just cut the 12-volt battery port, and so then you take all the systems down, and then you work with it exactly like you would with any vehicle. The one thing that, of course, earlier at least there was a worries that, okay, could I get shock from electric car? But people have to understand that it's a DC power source. So it has a plus and minus. It doesn't have a potential difference between the battery and the ground. So even if one of those plus or minus would be connected to the chassis somehow, you still couldn't get a shock from it. You would have to find both plus and minus at the same time, and you would have to be the shortest distance between those two. And it's really, really, really hard to do that, even if you would try. Whereas in my home, I just calculated I have 75 outlets. I can push something there right away and get a electrocuted from that. So from electric safety perspective, our homes are way worse than what electric cars are.
Yeah, I have one more question. You hear stories, newspapers or news organizations try to get a buzz for people saying you'll see a car electric car that's maybe 8 or 10 years old, and they like the car, they'd like to get a new battery for it, and it's quite expensive. Is there hearing anything about replacement batteries, if that's being addressed at all for cars? Because I hate to see these vehicles that are 8 years old, the body's in really good shape, but the battery's 3 times the cost what the car would be worth, that kind of stuff.
Yeah, right now, for example, for new Tesla Model 3, for example, the battery price for that is $12,000. So just get an idea about the price. But again, all the batteries have 8 years and 100,000-mile warranty on them. And I have yet to hear anyone having to replace the battery on their own dime. There has been some warranty work where they have had to replace the battery because of the warranty. Like Chevy Bolt had a big recall where they had to replace all the batteries. That's one thing, but not that the individual would have had to pay for it. We are expecting to see the batteries last at least 12 to 15 years in a normal use. The Nissan Leaf that you see behind me here in the picture is right now it's 9 years old, and it still has 80% of the battery capacity left. So that can easily be used until it's 15 years old or something like that. And of course, battery prices get lower over time, and there will be more providers for those. So I'm assuming we'll see lower battery prices when we actually start to need to replace some of the batteries.
Have you been seeing any new reports of a different type of a battery besides the NiCads or that they're using in cars mostly? Anything new?
Well, yeah, cars use lithium ions. NiCads are not used in electric vehicles. So it's a lithium ion technology that is used. Right now, it looks like lithium ion technology is the leading one. There are changes, of course, the battery chemistry all the time. There's changes to the battery management. There's changes to the battery packaging. There's a changes of maybe in the future, or for example, if they are going to be solid state batteries and stuff like that. But basically, it looks like lithium ion is the one that is leading the thing. Biggest change in the recent years has been that we've been moving away a little bit away from the NCM and other similar chemistries to more of a lithium iron phosphate chemistries that are much more cheaper to produce, and they seem to be working well also in EV usage. So that's one of the changes, but nothing huge. It seems to be just a gradual improvement every year, which is enough for me. Did we have any other questions in the chat, or anyone else have any other things?
How do I reach you with additional questions? Email?
It's best to just go to my website, shifttoelectric.com, and there's a easy form there just to send a note to me if you need anything.
Okay, great, thanks.
Yeah, and check out some of our events. If you go into the MNEV buyer, you can find our events list there. Also, if you go to mnevowners.org, you can find our event calendar there. And there's events all around Minnesota right now. So where you can go and see the cars, talk with the owners, see what they have to say, and some events also even test drive the cars. Just a couple of events that come into my mind. We have one event tomorrow in Duluth. So if you're in Duluth area, check us out there. We have another one coming in Hopkins next week, Bloomington after that, the weekend, and there are several other events that I don't even remember that are on our calendar. So you can definitely find them from our mnevbuyer.com or mnevowners.org webpage calendar there.
Anything else, members? Hearing none. Thank you, sir. Greatly appreciate your time. It's been very informative.
Yeah, thank you very much. You guys
Thank
have
you.
a good day, and hope you get to start driving electric soon, because it's sooner you do it, happier you'll be. That's how it works.